Welcome students. Now we are going to see videos on subject computer algorithm. In this video we are going to see detailedly about Mergesort in Unit 2. Mergesort. The properties of the Mergesort is it arranges the given values in order. What is the work of the Mergesort? Mergesort arrange the given values in order. Order means whether it is in ascending order or in descending order. It follows the divide and conquer technique. Divide and conquer has 3 steps. First, it divides the problem into subproblems and then conquer. Conquer means success. It finds out the solution for each and every subproblem separately and then combine together to form the solution to the given problem in divide and conquer technique. Now we are going to see working procedure in Mergesort. It has 3 steps as what we have seen in the divide and conquer. First step is it divides the problem repeatedly, and second step is it sorts the array. Third step is combine the array. Why we are specifying array here means the values to be arranged is given in the array. So, first step is divide the problem which is in the form of array continuously until it ended with a single value, and then we have to sort the array. Third step we have to combine the array. For example, this is the example problem. The value is given in the array. First step what we have to do to sort it in ascending order. First we have to divide. Then we have to sort. Then we have to combine. So we are going to see how it works internally. First step is divide. We divide the Mergesort based on the number of items in the array. Totally how many items in the array? 1, 2, 3, 4, 5, 6, 7. So total number of items is 7. To divide the problem into subproblem, we have to divide the total number of items by 2. While divide 7 by 2, we get the value 3.5. By rounding the 3.5, we end up with the value 4. So, we have to divide our given problem as like this. From 1 to 4, one subproblem. From 5 to 7 is another subproblem. It works like this. That is, from 4 to 6, it is one subproblem. From 7 to 1 is another subproblem. I am taking the subproblem separately. From 4 to 6 is one subproblem. From 7 to 1 is another subproblem. We have to leave these as it is and move to the left part first. Now this is our problem. That is, now our problem is having only 4 items, not 7 items. In this time, we have to consider this subproblem as an original problem. Then we have to do the step from the first. Here, the total number of items is 4. So, we have to divide. While 4 divided by 2, we get the value 2. So, from 4 to 2 is one subproblem. From 9 to 6 is another subproblem. We have to leave the right hand side as it is, move to the left hand side first. Here the total number of items is 2. So while 2 divided by 2, we get the value 1. So I am dividing my problem as subproblem like this. 4 separately and 2 separately. Then we have to leave this right hand side. We have to move to the left hand side. We can't able to divide it further. One is the step we have to stop. Apart from this, we can't able to divide further. So dividing part is over. The second part is we have to sort the value. Here 4 is there, right hand side 2 is there. We have to combine the array items as a single array by sorting. Here 4, here 2. While comparing the two value, 2 is brought first, then 4 is next. So we have merged the two separate array as a single array here. So it got the name Mergesort. What we have done? We have merged two array into a single array. So it got the name Mergesort. We are merging the item. That's why it got the name Mergesort. Then we have to move on to the left hand side. 9 to 2 items are there. We have to divide the subproblem until it has the single value. So I am dividing once again here. While I am dividing, I am getting 9 this side, 6 this side. I am end up with a single value. So I have to stop the divide process here. Then I have to start the combining process. While I am combining, I have to sort the array and I have to combine. So 6 brought first, followed by the 9. Then we have to merge the two sorted array. 2 4 is sorted array, 6 9 is also a sorted array. We have to combine. While we are combined, 2 4 6 9 we are joined together this side. So as for the original problem, left side of the portion is over. From 4 to 6 we have taken as a subproblem. That subproblem is divided continuously and merged. So this side of work is over. Now we are moving to the right hand side. While moving to the right hand side, there are three elements 7 3 1. We have to divide. How we can divide? We have to count the total number of items in the array. Total number of items is 3. 1, 2, 3. So 3 divided by 2, we get 1.5. By rounding, we get 2. So we have to divide like this. 7, 3 is one part. 1 is another part. We have to leave the right hand side first. Move to the left hand side. Here two elements are there. So we have to do once again the division. While dividing, we end up with a single value. So division process is over. Then we have to do the merge process. While we are merging, we have to sort the array and merge. So 3 comes first, followed by the 7. This side only single element is there. We can't able to divide further. So we have to merge the array into a single array. While we are merging, we are sorting and merging. So 3 this side, 1 this side. While we are comparing, 1 should be placed first, followed by 3 7. So by outline, what we have seen means this is the original problem. What 4 2 9 6 7 3 1 is the original problem. We divide first time the problem into two halves. 4 2 9 6 7 3 1. How we divided? Based on the total number of values divided by 2. Then we take the left hand side and sort it, and then we move to the right hand side and we sort it. Finally, what we have to do? We have to sort these two subproblems into a single problem. While we are sorting, 1, 2 is compared, so 1 is moved further, and then 2 and 3 is compared, 2 is moved next, and 4 and 3 is compared. 3 is moved for next, and 4 and 7 is compared. 4 is moved next. 6 and 7 is compared. Then we have to move 6. 9 and 7 compared. 9 have to move, and then finally 9. Like that, the values in the array are compared and lesser value is moved first. So we got the solution for the given problem successfully using the Mergesort, which follows the divide and conquer technique. Divided and find out the solution for subproblems independently, and then the subproblem solutions are joined together to form the solution for the original problem. So it follows the divide and conquer as well as we get the answer successfully. If we move to the advantages of Mergesort means we can use the Mergesort for sorting the larger file. For more number of items, Mergesort can be used efficiently to find out the solution. When compared to the array, which is a sorting algorithm which is available, Mergesort gives the value efficiently. It takes the running time much. If you compare the running time sorting algorithm having the larger file means Mergesort gives the answer in efficient time. In worst case also, it runs in efficient time. That means worst case means if you compare the 6 and 7s are the input itself 6, 7 is sorted. When we compare 4 to 9, the input here is very worst. Values are here and there, not nearer to each other. When the input are like this, also, that is in worst case also, Mergesort gives the answer in efficient time. Then disadvantage. When we speak about disadvantage, it uses lot of time, lot of memory or space when compared to other sorting algorithm which is available in the IT society. Thank you, students.